We are Project Polly, and our project looked at using a natural language processing interface to extract complex features from weather data cubes. So here you can see our names, Clive, Caitlin, Nadia, and our PhD projects. Now moving on to the motivation.
So in order to access and retrieve data from the ECMWF, you can either access via the Copernicus for free public available datasets. You can also access via an API for non-public datasets, or if you're a member, you can access it via the ECMWF website. So this further highlights how challenging it can be to extract and retrieve data directly from the ECMWF. But what about unfamiliar users? What about users who don't know anything about the weather domain? So we asked here ChatGPT to retrieve some data for us, and it came out with a Python code that might not be easy to comprehend for people who don't know how to code. So more specifically, how can a non-familiar user extract time series, 2D cutouts, shapefiles directly from the ECMWF dataset? This then further sets our objectives. So our main aim is to create a chatbot that can retrieve data from Polytope. And then as a second goal, it would be nice to have a web user interface, easy for users to interact with and then easily retrieve data. But first, we need to understand how is this data managed and how is it organized, right? So we have MARS, which stands for the Meteorological Archival and Retrieval System. It's the data management system designed by the ECMWF to store and retrieve meteorological data. This system supports a wide range of data that optimizes high performance data access. But how do we only access the data we want? So here comes Polytope. So for each data set within MARS is composed of multiple data cubes. However, the user doesn't want the whole data cube, as it's a large data set. So then Polytope allows to handle complex queries and massive data sets efficiently, and only extract the data that the user wants.
Now on to the background. So an LLM is a type of natural language processor. I'm sure you all know this. We can use it to respond in a human-like manner. So what is RAG? RAG stands for Retrieval Augmented Generation. It can be used to improve the accuracy and the reliability of AI. We use the documentation from the MARS for the RAG to use. So instead of giving a weighted answer, the AI will first look at the documents that it's been given.
So we've explored different, let's say, aspects of this project. We first explored fine-tuning. Fine-tuning is just the process of adapting a pre-trained pre-trained model to a specific user case. However, fine-tuning can be very efficient for simpler tasks. We did manage to come into a few challenges, especially because the volume of the data is big and it's complex to just fine-tune it. So given these challenges, as a team, we decided to not follow fine-tuning and maybe leverage pre-trained models with advanced prompt engineering, as many of you might know, with the launch of ChatGPT. So what are the components of LLMs? We're here specifically talking about agents, which are just the evolution of prompt recipes. They can be very useful and simple to use, depending on your task. However, we did run into a few debugging and integrating challenges, as well as we did deem that it was not cost efficient at all. So here, one more, sorry. So here we could see that an LLM agent is made from 3 components: the LLM, which selects the right action in a given situation; the agent's memory of previous messages and results is the state of the LLM; and finally, the tools, which is the agent's ability to interact with the external world or the user. However, the main limitation of these agents is that there is no standard approach and they're quite manual to set up. And here we just have a few agent frameworks that could be of use to many of you, or maybe you have already interacted with these in the past.
Can you hear me? Maybe I'll use the microphone. Oh, how's that? No, I'll use the microphone. Okay, so just very quickly to demonstrate and kind of let you know how we are trying to essentially get this request. So we use, obviously you need to use JavaScript object notation, so it's a hash map or an associative array if you use that. So you essentially have a set of unique keys and a set of values that this is what we're trying to generate from the user prompt. So maybe they say, I want the weather forecast data for Germany. So how would we turn that into kind of this structure? Next slide. Yeah, and then it's an interesting one. At the start of this project, some of the tools available weren't available, and we'll come to that in a minute. But one of the things that was quite useful is essentially testing out your prompts and trying to add in your own prompts and kind of enhance what the user is trying to get from the model. You might have seen from some of the newer models on OpenAI, it's sometimes, especially nowadays, if you use the most recent one, you'll see it has that little section where it's trying to think, and this is that chain of thought process that's going on. So essentially what they're doing, they're getting one output from the LLM, thinking about it, using that as an input, and then trying to refine and make a better answer. So that's why you see the models improving at such a rapid pace, because it's essentially just retesting its answer. Okay, and I'll very quickly go over this. So prompt engineering is super useful. Kind of one of the points that was touched on earlier was the kind of that user expert knowledge, the subject matter expert. That really helps, because if you know exactly, if you can, essentially, it's as powerful as you are, it's as good as you can make it. This is good, but it's also bad, because then, you kind of get bias. Not everyone can use the models in the same way, so that's kind of where, that comes in. And kind of the unknown, this is that prompt engineering, so it's also an attack vector. So you might have seen some LLMs that are able to generate API keys, or they're able to get past the kind of safety measures, and it can do the things that we don't really want these LLMs to do. So that's kind of one negative of that. Okay, on these prompt models, so there's an example here. It's a very simplified example, but essentially all we're trying to do is say, ChatGPT, is the weather good today in my area, or is it not good? And you can see the response here is not too useful, and it's not structured in the way we need it. We need it to feed into another model. For example, maybe this goes to a web front end, and it shows a nice big red flag or green sunny day, if it's a good thing. Here you can see the model is not able to parse that answer until we see here. The way you'd get around this is you'd feed in a system prompt. So you wouldn't just use what the user has said. You would give the system a way to kind of understand and interpret the data. So the forecast could be an API call. It gets the weather around the area, and then with your system prompt, you can say, okay, in general, if it's this temperature, then it's probably an okay day. As long as it's not raining, then you can say, yeah, the weather's good for a picnic. And then this is a graph that I showed in the last call. Big red X I've added to that, because essentially the way the models are working now, they're getting better, and the way that you would in the past, when we first started this project, you almost had to beg the model to please output JSON in a correct format. And if you didn't, it had to kind of retry and test again. Nowadays, you'll see later, I'll introduce something where they are getting much better, and a lot of this is automated now. So yeah, getting LLMs to output JSON. As I say, some of this is out of date almost, but this blog post, if you read that, that's probably the best place to go. The benefits of using JSON is that you can use that in Python functions, you can use it in anywhere, really. It's interoperable, you can kind of move it around. So it's not just for the LLM to get your request for ECMWF, it's also a way for the LLM to be able to use those tools and go around that. And then, yeah, this is quite an important part, I think, and it's especially true now, that good LLM validation, it's just good validation. So if you know exactly what you're after, the object that you're trying to feed into a function, for example, the way you need to do that is just define it well and specify exactly what you need. At the start of this project, it could use this. There was JSON mode. It was available, but it wouldn't follow the schema strictly. So, for example, if you see this user detail model, it's a pedantic class, which we'll go into later. There's a name, which is a string, and an age, which is an integer. Previously, it might not get the string and integer bit correct, even if you use the JSON mode from a year ago. Nowadays, with some of the tools that OpenAI is producing, it can do that validation with the first API call.
Moving on to implementations.
Oh, sorry. Yeah, so we actually, it's quite an exploratory project. Over the course of the actual project, things changed. The ways you kind of use these tools changed. And some of the things I won't mention, but I just want to quickly, briefly talk about if you want to talk to me during the break. So essentially those agent frameworks that we mentioned, function calling, so essentially letting the LLM decide how to use different tools. Alternative models, which was touched on earlier. So Llama is this very promising model. It's locally run, so it can be a lot cheaper if you've got some infrastructure there. Fine-tuning, very useful for this use case, but kind of need some sample data for that. And then I guess the DevOps side, some of the ECMWF tools and the tech stacks, they can be quite complex to get started with and kind of integrate. So that's where you kind of want this DevOps side and maybe have a very easy to use shareable environment. We'll very just quickly talk about that. And then, yeah, our approach in the entire project was essentially to mimic what you are used to using with these chatbots, OpenAI, for example, and essentially just hide all the complexity from the user because they don't need to see that. And that's where this kind of architecture comes in, the front end and the back end. The front end is the bit you're all used to with any chatbot. You just talk to it, you get an answer. That gets sent back to the server. In our case, essentially what the chatbot can do is it can test and see if there is any missing information. If so, it'll feed back to the user and say, actually, you need to tell me this because I can't just guess. I was not thinking, but maybe who knows. The next step is to just validate that JSON, make sure it's actually parsable by the machine, and then also kind of go one level deeper, which is that schema validation. All the types are correct, the values within certain bounds, and so on. At that point, you can send that request away to Polytope, the library which lets you really get that data efficiently. And then this bit in the red box, so that's the kind of nice to have. And some of the back-end parts we'll talk about later. We essentially have some of this, but integrating it and kind of making that into a product is quite difficult at the moment. And we'll talk about that in a second. So yeah, back-ends.
Here we can see the results of the RAG. You can see at the top we've asked it what is Mars, and at the bottom it's given the definition of Mars. This AI uses only the specific knowledge from the documentation we gave it, so it doesn't search the internet or anything.
One of the most important keys of the backend is validation. So after the chatbot has successfully generated a request, or if the user can handle the data and knows how to generate a request, it has to be validated, and for that we used Pydantic, which is a Python library. So we need to first understand that this generated request meets the schema. So for that, we used regular expression, like we could see on the image here. For an example, everyone knows that an email starts with a series of alphabets and numbers, and then you've got the @ and then you've got the local domain, and then the commercial domain. So that's what we were planning, like that's our main goal. So for that, we have here the class Mars request, which has a nested Mars request feature class as well. And for example, we could see that the date, we have specified the schema of the day, so year, month, day, etc. This way we know exactly whether the request meets our regular expression.
Yeah, and then very quickly on the back-end side, even though this is essentially one of the foremost front ends you'd want to use, OpenWebUI is very useful as a back-end. You could actually just use the back-end. You don't even need to use the front end on this section. Why is it great? Because it's under active development and it's very extensible. So if you're going to build a large system, so you've got multiple components. So for example, integrating the previous talk's work, you'd probably want to have one user interface, and then all the complexity is hidden. And OpenWebUI is probably the best tool for that if you've got multiple services on the go. And then, yeah, as I mentioned previously, this is hot off the press, I guess, early August. OpenAI kind of introduced their structured outputs. They had JSON mode previously. What is structured outputs? Well, it's essentially just going that one level deeper, and it's really checking the schema is 100% valid. It's not just checking the keys and the values are roughly correct and there. It's also checking all the data types. It's checking if the values within the range you set, and hopefully in the future, not right now, it doesn't allow regexes directly, but you can imagine that's something they'll probably add quite soon and probably the way to go. So what did we use instead? We used Instructor. It's a library which is very useful, and it was probably the best choice, and probably still is the best choice to use when you're trying to generate these outputs. And you can see on this right-hand side, there's an example. What is it doing? First of all, it's just testing if it makes the OpenAI request. It tests if it's valid, if there's anything wrong. It tries to fix anything small itself without having to incur an extra cost. And then you can see, if it has a big problem, it'll send another request to OpenAI and say, this is the problem I got, and can you please fix it? Front ends. So I think we can go over this bit quite quickly. There's various front ends. Once you've got a backend set up, maybe a data scientist wants to use a Jupyter Notebook, and that's their workflow, and they'll use that request. You can see what essentially the example output. So you've got the user asks for something and gets the kind of request that they need, and then they can then use that to make that Polytope request. ChatGPT Builder, which we talked about previously in our other slides. So you can integrate this into this front end. It's one example. I'll just move on for that. And then another one, this one's very useful. It's quite a user-friendly one that Nadia found. I'm not sure if the video is going to play. But yeah, as I said before, OpenWebUI, this is probably the premier tool. And if you've got multiple components, probably use this. What do we use in the end? We use Streamlit. And you can see actually there's a map there as well. So it's not just the traditional chat interface. What we found was that LLMs, unless you really have a fine-tuned model, or you kind of go in depth, you provide a list of areas that are acceptable, it's not going to generate those well-known text polygons very well. So what's an alternative? Just draw it on a map. And probably the best, you want to use the correct tool for the right job, I guess. Future work. So yeah, if we knew what we know now, what would we do differently? So there's kind of three elements here. I'll just quickly go through them. So the separation of concerns. We've touched on a lot of different topics, but you can see we've kind of got the data retrieval from the ECMWF and the validation of that, the model tuning and selection as well. So using Llama, for example, as mentioned. The DevOps side was a task in itself, just trying to get all these components fitting together, especially the ECMWF, all the various libraries that are available. And then the front end, back end, making sure it's very reproducible and deployable on anyone's machine. That chat flow as well. I'll move on to limitations.
Okay, so throughout this project, we did explore different front ends, back ends. We've explored different methods, so that's why we feel like we've learned quite a lot from this. But there are a few limitations. Starting with using different agents, different tools, different fine-tuning techniques, different prompts, actually give very different results as seen here on the plot. So also one limitation that might not seem like a limitation, but is quite big, which is that models are constantly ongoing change. So we do produce something today, and then the next day it's not working because they've developed a model and they've made it even better, but your prompt might not work correctly. And I would like also to highlight that the API was harder to implement, and we do feel like it's a bit premature to handle a chatbot for the moment. But we were still able to create something at the end, which might not be perfect, but still works really well.
We can see a sample request. So in future, in a perfect world, we'd have loads of previous requests that we can then use a chatbot to train on these requests and then fine-tune the model. But unfortunately, we just don't have access to that data.
Yep. And then very briefly, just kind of the key deliverables that you'll find on the GitHub page once that's open. So Project Poly itself, so you have a conversational assistant, which you can use to help you with those Mars Polytope requests. There's a Streamlit app where you can draw your polygon. That's probably useful in itself. You can probably just take out the component. So it's a TerraDraw, a very useful library, so you can kind of use that to create polygons for different use cases. The validation was a key one. Pydantic, very recommended. OpenAI, and also kind of this isn't really a deliverable, it's more of a comment, but just I think the local model is getting a lot better, so probably want to pay attention to, because obviously you don't need to pay as much money. There's notebooks and there's branches that are kind of looking to agents and frameworks that's available on the GitHub. And probably the key thing I'm quite proud of is kind of like GitHub Codespace, where we're able to just, because it was quite a difficult environment to set up, so if everyone do it on their own computer, everyone can have different problems, if we're using Windows or Mac and so on. So if everyone's on the same environment, it's quite a good little thing, and I think if you want to replicate that, it's quite easy to just copy that code. Thank you very much for your time.